Now that you've had a chance to complete the table and consider the question and see what your classmates thought, let's address them together. As n increased, the sum of the areas of the rectangles for each approximation method approached 9. This could be a good indication that the area, or the distance the particle traveled, is about 9, since the area under the curve looks like it is approaching 9. This estimate was done with a finite sum. As our finite sum of the areas of the rectangles increased, our area became more accurate. In order to show the work for large sums in a compacted form, we use something called sigma notation. Sigma notation enables us to express a large sum in a compacted form. The Greek letter sigma stands for sum. The index k tells us where to begin the sum at the number below the sigma and where to end at the number above. If the symbol infinity appears above the sigma, it indicates that the terms go on indefinitely. The sums in which we will be interested are called Riemann sums, after mathematician George Frederick Bernard Riemann. Left rectangular approximation method and right rectangular approximation method in the previous section are examples of Riemann sums, not because they estimate the area, but because they were constructed in a particular way. We now describe that construction formally in a more general context that does not confine us to non-negative functions. Thinking back to the table you completed on your capture sheet, what happened as you increased n? If we continue to do this, what happens to the shape of the rectangles? Pause the video and answer the question. Going back to your table and using the GeoGebra applet, what do you notice happens to the shape of the rectangular approximations as you increase n? Record your answer on your capture sheet. Hopefully you noticed, as the partitions of AB become finer and finer, we would expect the rectangles defined by the partitions to approximate the region between the x-axis and the graph of f with increase in accuracy, or that the region becomes closer to the shape of the curve rather than partitioned rectangles. The definite integral of a continuous function on AB. Let f be continuous on AB, and let AB be partitioned into n subintervals of equal length delta x equals the quantity b minus a, all divided by n. Let's stop there for a moment. In our example, our interval was from t equals 0 to t equals 3. Those are the a and b values. When we had 3 intervals and a total time interval that was 3 units, 3 minus 0, or 3, divided by 3 gave us subintervals that were each 1 unit wide. When we had 6 intervals, 3 minus 0, or 3, divided by 6 gave us subintervals that were each half of a unit. As we increased the number of subintervals, we were always dividing 3 by the number of subintervals to get the width of each. Now here's our definition. The definite integral of f over ab is given by the limit as n approaches infinity of the sum of f of c sub k times delta x sub k from k equals 1 to n, where c sub k is chosen arbitrarily in the kth subinterval. Let's unpack this formula. Delta x is the width of a rectangle. F of c sub k is the height of the rectangle. We can use the height to be the height at the left side or the right side or somewhere in between, like the midpoint. It doesn't matter. If our velocity function is continuous, the limit is the same no matter how we choose to do the height. Then we are adding up all the areas of the rectangles and taking the limit as the number of rectangles increases to infinity. Pause the video to record the definite integral of a continuous function on your capture sheet. Terminology and notation of integration. Pause and rewind the video at any time to record any information about the explanation of notation. Let's go back to something we learned when we studied derivatives. We use delta y to mean the change in y, and delta x to mean the change in x. The slope of the line segment connecting 2 points on a curve, also called the average rate of change, was delta y over delta x. When we took the limit as the 2 points came together, we got the slope at a point, which we called dy over dx. As we took the limit of the Greek letters, we got the Roman letters. This notation was the idea of Gottfried Wilhelm Leibniz, one of the inventors of calculus. More terminology and notation of integration. The limit as n approaches infinity of the sum of f of c sub k times delta x sub k from k equals 1 to n is equal to the definite integral from a to b of f of x dx. Terminology and notation of integration. The limit as n approaches infinity of the sum of f of c sub k times delta x sub k from k equals 1 to n is equal to the definite integral from a to b of f of x dx. Notice that the difference delta x has again become a differential dx. The Greek sigma has become an elongated Roman s, so that the integral can retain its identity as a sum. The c sub k's have become so crowded together in the limit that we no longer think of a choppy selection of x values between a and b, but rather of a continuous unbroken sampling of x values from a to b. F of x times dx represents the area of a rectangle, and it's as if we're adding up the areas of an infinite number of infinitely narrow rectangles that fill the area under the curve from x equals a to x equals b. The definite integral. Here we are going to go over notation for the definite integral. Here we have the definite integral from a to b of f of x dx. This elongated s is the integral sign. The a is the lower limit of integration. The b is the upper limit of integration. F of x is the integrand, and dx is the variable of integration. Pause the video to record the definite integral and its parts explained on your capture sheet. Example 2, using notation. Express the limit as a definite integral. The first example is the limit as n approaches infinity of the sum of f of c sub k squared delta x from k equals 1 to n for the interval from 0 to 2. What you need to do here is take the limit notation and write the function in integral notation. The answer is the integral from 0 to 2 of x squared with respect to x, or you can say dx. Pause the video now and record the answer on your capture sheet. Let's try another one. The limit as n approaches infinity of the sum of the cube root of 8 minus f of c sub k cubed delta x from k equals 1 to n for the interval from 0 to 1. Again, what you need to do here is take the limit notation and write the function in integral notation. Pause the video now to try to do this one on your own on your capture sheet. The answer is the integral from 0 to 1 of the cube root of 8 minus x cubed dx.